Hey y'all, do you know what I love doing? Rewriting notes for the third time because my computer decided not to save it. So let's do this. We are factoring quadratics. All of chapter 3, the entire thing, is for you to solve a quadratic equation. Solving means finding the x-intercepts. That's all it really means. Now, we haven't talked about this, but factored form is the quickest way to find x-intercepts. And so I'm going to show you how to get from standard form to factored form, and then solve it really quick to find the opposites. Have you been taught factoring in the past? Yes. We teach it to you during Algebra 2. Did every teacher teach it the same way? No. Different teachers teach factoring different ways. So I'm going to teach you the way that makes the most sense to me because that's how I'm going to factor during my notes. But I have, I'm prepared for alternate methods. So watch the other video if this doesn't make sense to you. I want something to make sense to you for factoring. Is factoring a scary thing? No. Do you maybe have bad feelings about it from factoring in the past? I don't know. It really depends. But factoring, the only hard thing about factoring is the mental math that goes with it. What times what makes whatever number and adds to get the other one. But I'm going to show you some tricks too in that other video. So again, I'm just going to show you really quick my specific method. I'm going to say using X puzzles, which I'm going to be honest with you, I'm recording this before the class where I'm going to walk through what X puzzles are synchronously. And so I'm going to have the most faith in myself that I'm going to do this well so that way I don't have to do it again and record this for the 4th time. Whoop, whoop, let's do it. No. So again, we're going from standard form to factored form. So standard form was ax squared plus bx plus c. Factored form has 2 sets of parentheses in it, which you'll see a bunch of today. So let's just jump. No, I'm going to leave some space here for steps. I'm going to leave space here for 3 steps. So we're going to come down here and do an example, but then I'm going to go back and fill in the steps after that, because why not? So let's do something that's already set up for us. It's nice. It's in standard form. It's so pretty. This is already in standard form for us. So what we're going to do is we're going to put that in we're going to draw a big old X. Here's the tricky part to this. The last number goes on top. So the 16 goes on top. And then the 10 goes on bottom. And the reason we do that is because there's less numbers that multiply to get something than there are that add to get something. So what we do is we're going to have the 2 side numbers are going to multiply to get the top number, and they're going to add up to get the bottom number. So what times what makes 16? There's only a couple options. But what plus what makes 10? There's a million, because I could keep subtracting. So what multiplies to get 16? I know that 1 times 16 is 16. I know that 2 times 8 is 16. And I know that 4 times 4 is 16. So out of those 3 options, those 3 factors, what would add up to get 10? That would make 17. That would make 10. So it's going to be 2 and 8. And then what we get from that is that we get that x plus 2 and x plus 8 equals 0. So I'm taking this standard form right here and I'm changing it to be factored form. So this is factored form. Isn't that beautiful? I'm going to color code where all the numbers came from and where they went in a second, but for right now I'm just going to keep solving. So x minus 2. Everybody say hi, Machka. X plus 2 times x plus 8 equals 0. What I'm going to do is I'm going to multiply both of those, or no, I'm not. I'm going to use the 0 product property. So x plus 2 can equal 0, or x plus 8 can equal 0. Those are my 2 options for it to equal 0. Because if this equals 0, 0 times whatever equals 0. And if this one equals 0, then the same thing happens the other way. Pause for lighting. Much better. I had opened the window up. And then a train came. Okay, so now I'm going to solve these. So what I'm going to do is I'm going to subtract the 2 over here. So I get x equals negative 2. And then I'm going to subtract the 8 over here, and I'm going to get x equals negative 8. And those are my 2 solutions. And this can be any of these words. So if it asks you for the solutions, it's looking for those two numbers. If it asks you for the x-intercepts, it's looking for those two numbers. You might want to put them in a point, but it's the same. If you're looking for zeros, it's going to be those two numbers. Or if you're looking for roots, it's going to be those two numbers. Those are all 4 different ways of asking you the same thing. Let's do another one. Also, I color coded. Did you notice, by the way, that these two numbers just got swapped? They got negatived. They got opposited. Those are not words. It's going to be that way the whole time. So I'm going to stop setting it equal to 0 and solving it. So for this one, I need it to equal 0. It has to equal 0 to be able to solve it. So I'm going to subtract the 4x. Now, I can't put the 4x with this x squared because it's not the same thing. There's no x squared on it. And I can't put the 4x with this 45, but I really want it to be in the middle for it to look like standard form like the last one. So we're going to have x squared minus 4x minus 45 equals 0. And then what we're going to do is we're going to factor that. Same thing, make a big ol' X. The negative 45 goes on top. The negative 4 goes on bottom. And I need them to multiply to get the top and add to get the bottom. So what multiplies to get 45? Well, I know that 1 times 45, 3 times 15, and then because it's 15, I bet 5 also. So let's see, 5 times 9. So those are my 3 options. Because if I keep going, I'll get 15 times 3 and so on and so forth. So which of these, if one of them is negative, makes negative 4? Because they can be negative. 1 is negative because it's negative up here. Well, 5 and 9. So if I did a positive 5 and a negative 9, that would make negative 4. So my factored form is x plus 5, x minus 9 equals 0. And then if I use the zero product property, I get x equals negative 5 and x equals positive 9. Shout out to Mac from last year who kept telling me to flip that boyo. I still do it, buddy. So those are my 2 solutions, or those are my 2 zeros. I'm going to pause and go back up and write those. My light just flickered. Write those solutions and highlight some things, and then we'll do one more example that you can try on your very own. Okay, so here's our steps. We set the equation equal to 0. We factor using the x puzzle. The last number goes on top. The middle number goes on bottom. We multiply and add. And the solutions are the opposites. So if it's a positive 2, it'll be a negative 2. When it was a negative 9, it'll be a positive 9. They switch. All right, let's try one more. X squared minus 12x equals negative 35. You are completely capable of doing this problem now, but if you want to, you can pause it, try it, and then press play again to watch me do it. So I need to add the 35 over here, but again, it can't go with the x squared and it can't go with the 12x because it is just a number by itself, so I'm going to put it on the end. So x squared minus 12x plus 35 equals 0. Put that in the x puzzle. 35 and negative 12. What multiplies to get 35? 1 and 35, 5 and 7, and that's it. Well, how do I make a negative 12 out of those numbers? Well, these are way too far apart. But 5 and 7 make 12, so if I do subtraction, if I do both of them negative, it'll work. So negative 5 and negative 7. I should do the same cross out thing up here since I did it down there. OCD for the win. So now I get, also I apologize if somebody has diagnosed OCD and you know it's not just things not looking the same. I know that a lot of OCD is aggressive hand washing, overkill, tapping on things. So I didn't mean to make light of your situation. X equals 5 and x equals 7 are my 2 solutions because they're the opposites. Okay, normally in Algebra 2, I would also teach you what happens if there's an A value or a stretch. In this specific case, I'm not going to. Somebody else who's a math teacher can get mad at me for that. This entire time I've been on the geometry one. I need to just get rid of that. I've done that twice now. The last time I freaking recorded this, it was correct, but it didn't save. So yay me. Anyways, so having not having an A value makes it a little bit simpler, and I just wanted to like get you into it with your feet wet this way. I'm going to teach you 4 total methods of solving. Maybe it's 3. I'm going to teach you at least 3 methods of solving quadratics. And I didn't want to overburden you with, okay, if it looks like this, you can do this with all the methods. Basically, I wanted you to know that factoring's super good if there's no A value, and it's also super good if the numbers make sense together. But we're going to talk about other methods and other ways to do this that also make sense. So don't worry about it if this doesn't make sense. How many times can I say make sense in a sentence? And then watch the other video if you want other methods. If your teacher taught you something different and you just want a refresher on it, please watch those ones. Every time I do notes, I'm going to be factoring with these X puzzles, so you might want to get used to the idea. But if they're confusing, pretty please watch the other one. I'll give you tips and tricks. I got your back. I'm not here to trick you. I'm going to color code this. Hold on. All right, there you go. And I will see you whenever I see you. Okay, bye.